Alrighty, uh, let's see if I can do today's coding. I've been under the weather for like a week, and I'm still not over it, but I think I'm gonna try to restart the streak here. See how it goes. Alright, range product queries of powers. Given an integer n, there exists a zero index array called powers, composed of the minimum number of powers of 2 that sum to n. The array is sorted in non-decreasing order. There is only one way to form the array. You're given a zero index 2D pure array queries where queries of I as left sub I, right sub I. Each query of I represents a query where you have to find the product of all powers j, where left of I is less than or equal to j less than or equal to right of I. Find the product of all powers. Return an array answers equal in length to queries where answer of I is the answer to the ith query. Since the answer to ith query may be too large, the answers of I should be returned modulo 10 to the 9th plus 7. Okay. Pretty complicated setup. So if you have n is 15, and then these are queries, and the output is 2, 4, 64. So for n is 15 powers, so powers is an array of powers of 2 that sum to 15. So that would have to be 1 plus 2 plus 4 plus 8. And the first query is 0, 1, which means you take the product of the element as 0, index 0 times element of index 1, which is 1 times 2. Query 2, 2 is going to be multiplying 4 by its 4, and that's it. And 0, 3 is going to be multiplying all of that, which ends up being 64. Okay, and then n is 2. The powers would just be 2. 0, 0 would just be 2. Okay, so I think the first thing I need to do is to convert n into something like this. The powers that sum to it. Here, I think because you're really multiplying the queries themselves are multiplying powers of 2, the answer to any query is going to be a power of 2 itself as well. So this is 2 to the first, 2 squared, 2 to the 6th. And in particular, it's going to be the sum of the powers that are being multiplied. So if n is 15, if I think about the powers not based on the actual value, but the exponents, say powers would normally be considered 1, 2, 4, 8, but like exponent of those powers would be 0, 1, 2, 3. And so the queries would be the answer to the query. Answer to query is sum of exponents at indices in range of query. So example, if the query is 0, 0, 3, then we're summing exponents from index 0 to 3, which ends up being 0 plus 1 plus 2 plus 3, which ends up being 6. So the answer is going to be 2 to the 6. So I need to convert n to some exponent array. Okay, so convert. Why is this not tabbed correctly? So convert n to exponent array. where sum of two exponents is equal to n. So I think I could possibly consider n as a binary. So if you have 15, or yeah, if you're converting a number to binary form, the bits where you're dealing with 1 is a bit where you have a power of 2 that would be part of the sum. Okay. If considering n as binary, bits where bits that are 1 equates to power of 2 in the power of 2 needed in the sum to n. Okay. So I think I can do something like while n is greater than 0. Let's go ahead and say exponents. So yeah, exponents. It's going to be an empty array, I think. And I think I need to have an actual power thing. Okay. Well, n is greater than 0. So every time I have a 1 bit, n has to be greater than 0, right? N is 1. Yeah, okay. I'm just looking at the constraint here. I take the last bit of n, and that, okay, so the last bit is going to be n and 1, bitwise and. If the last bit, actually I know I need to increment power at some point. If the last bit is 1, I could also just say if last bit, then whatever power this is needs to be added. Exponents dot append this power, and then power plus equals 1. And then n needs to shift, n needs to divide by 2 or shift down. And bitwise n equals n shifted over 1, I think. Bitwise shift Python. It's x, returns x with bits shifted to the right y spaces. Yeah, I think that's right. Okay. Shift over 1 space. You could also do this as and I think that's the bitwise shift and assignment operator. Looks really weird though. Too weird for me to use with full confidence. Okay. So it shifts over 1, which divides by 2, which gets you to the next power that could be there. Okay, let's go ahead and just print out the exponents to verify. So the first value should just be 0, 1, 2, 3, 4, or 0, 1, 2, 3. And this is 1 because in the sum of the powers of 2 that adds to 2 would just be to the first. So that's only 1 power 1. Okay, so then the queries now. So let's go ahead and create the answer array. and then for every query. So actually, I think I need to make the thing with the queries, right? It's going to be if you have queries between two indices, I think it's just the sum of all the things within those indices. So I think I need to probably make a prefix array. So prefix array to quickly sum certain intervals within the exponents array. So let's go ahead and make this prefix. Generally start with 0 for every k in the exponents. Prefix.append k, k plus prefix, the last prefix, sum. Make prefix array to quickly sum range of indices of exponents array. So prefix array, if I wanted to sum 0, 3, it'd be like taking the prefix at 3, subtracting the prefix at 0, something like that. Maybe off by 1, but pretty close to that. Okay, and then for every query, so let's say start, end, and queries. So the total power is going to be the prefix at this end minus the prefix at the start, I think. Let's think about this. So it's going to be 1 minus 0. Is that right? So prefix at 1. Okay, let me go and just print out the prefix here. Print out the exponents array and the prefix. Okay, so the first answer should have been 2 to the first. This should have been queries at n plus 1 minus queries of 0. It needs to be inclusive of this thing, so it generally is going to be, so it has to be n plus 1, end plus 1, and then not inclusive of this thing. So it should be start yeah, I think it's end plus 1 minus start. So if it was 0, 3, then it should be 6 minus 0. So that's 2 to the 6. 2, 2 would be 3 minus 2. 0, 1, 2, 3 minus 2, so that's 2 to the second, which is 4, which is the answer. Okay. So that's the total prefix, or that's the total power of 2 for the query. And I think it just would be answer append 1 shifted to the right, the total amount, which is the 2 to that power. 2 to the 0 power is 1. Yeah. And then modulo by whatever, if necessary, and then return the answer. I don't know if this is really that fast, but we'll see. It might be that this is still pretty slow. Uh, okay, guess that's fast enough, I guess. I was wondering, like, yeah, I'm not sure how fast this is. Like, taking one bitwise operation to shift it over some number. But, okay, whatever. Modulo my exponents, my power thing here. Well, and it's greater than 0. The last bit equals 1. I wonder if I should delete the equals 1. It's fine. Exponents dot pen power. And this is the same as that. Power increments, answer, empty array. Actually, the answer probably should be declared here instead. Okay, so prefix, let's say use prefix array to some ranges of indices of exponents array. Okay, actually this is the construction. Prefix array based on exponents array. And here is when I use the prefix array. And this thing is just, so this is, here I can just say note 1 to total that expression calculates 2 to the power of total using bitwise shift. So the thing that you append to the answer array is 2 to some power, 2 to the total power. And this is just calculating that using bitwise shift, which I think is quicker. Alright, so the summary here is going to be, so there's just a few main components, I guess. One is to find the powers of 2 that sum to n, which is equivalent to the which is easiest to find if considering n as a binary number. The bits that are 1 are this correspond to the powers of 2 that are present in the sum. Then once you kind of think about that, then create an exponents array that are the exponents of the powers of 2 that sum to n. So that was this thing right here. This can be done in various ways. Above, use bitwise and bitwise operators to calculate that. And then next step is, as queries correspond to multiplication of powers of 2. That corresponds to sum of exponents of those powers. To quickly calculate the sum of indices of the exponents array. Use a prefix use a prefix array based on that. So then the next part was just creating this prefix array based on the exponents array. And then lastly, create an answer array that will get the power of 2, get the sum of that will answer each query by using the prefix array at the appropriate indices, and also moduloing the value as necessary. So that was this thing. This total is total exponents based on the sum of the exponents of the queries. Alright, and then let's manage it. Time complexity, this is going to be O of n in many, many ways. What's this? N is 10 to the 9th. So O of n, well, O of q, where q is the number of queries. For construction of the exponents and prefix array, that is constant as n is 10 to the 9th, which converts to basically 32 operations needed to create, which goes to basically 32 operations needed to create the binary kind of conversion. Space complexity is going to be O n, where space complexity, this can be O of, what is this? This might be O of 1 kind of prefix. Yeah, it's still kind of O of 1. This prefix array is capped to 32 kind of bits or values. Yeah, I think that's